In this video, I will walk you through free response question number 3 from the 2004 AP Calculus exam. This is a calculator active problem. Problem number 3 is primarily about the relationship between position, velocity, and acceleration. A particle moves along the y-axis so that its velocity at time greater than or equal to 0 is given by this equation. At time t equals 0, the particle is at y equals -1. Find the acceleration of the particle at time t equals 2. Since this is a calculator active problem, let's start by typing this equation into the calculator. When I do a position, velocity, acceleration problem on the calculator, I always like to put the position function in y1 and the velocity function in y2 and the acceleration function in y3. That way I don't have to try to remember which one is which because I always do it the same way. So we're typing in a velocity function, so I'm going to put it in y2. And it was it was 1 minus the inverse tangent, so second tangent, and then it was e to the x power. So I'm going to do second, so I've got my e to the x, and I'll just go ahead and put the x in there. I think on the actual AP exam it was a t, but we're just going to stick with x. And let's close that off. So we've typed it in. For part A, we need to find the acceleration of the particle at time t equals 2. So we need to find acceleration at 2, but we know that acceleration is the derivative of velocity. So we need to find v prime at 2. The calculator will do this beautifully. So let's quit to a blank screen. If you want to evaluate the derivative of a function, you can use the math functions, and function number 8 is the derivative. So I'm just going to press 8. So I'm going to differentiate with respect to x because that is my variable. Now I want to use the function that I typed into y2. Here's how you get y2 right here without having to type the whole function in. Hit the vars button, and we want yvars, so just go over there and choose function. And so here are the functions that we could type in. We typed the velocity into y2, so I'm going to choose that and hit enter. So this is the derivative of the velocity, and I want to evaluate this at x equals 2. So here it is. Kabam! This is it. So we're going to use 3 decimal places on the AP exam. So I'm going to call this negative 0.133, but the AP exam would also accept negative 0.132. You can truncate or round properly. But I like to round, so I'm going to put negative 0.133. And that's the answer to part A. Part B, is the speed of the particle increasing or decreasing at time t equals 2? Give a reason for your answer. Here are some notes that you need to understand this problem. The speed is increasing if the velocity and acceleration both have the same sign. For example, if the velocity is positive and the acceleration is positive, then the speed is increasing. On the other hand, if the velocity is negative and the acceleration is also negative, again, the speed will be increasing. We already know that the acceleration is negative. So let's go ahead and find the velocity at time t equals 2, so we can see if they're both negative. Once you have typed a function into the calculator, an easy way to evaluate the function at a particular value of x or t is to use the table feature. So I will hit second table, and now I can just type in the value at which I would like to evaluate. So I want t equals 2, which we're using x, so x equals 2. And there it is. The value of function 2, which was the velocity, is negative 0.436. By the way, if I needed more decimals, I could just highlight it and here's a bunch of them. But 3 decimals is perfect for the AP exam. So negative 0.436. So I'm going to say that V at 2 is equal to, wait, I already forgot what it said, negative 0.436. Negative 0.436. Notice that these are both negative, so therefore the speed is increasing. For my explanation, I am going to list the velocity at 2 and the acceleration at 2 sort of side by side, and I'm adding this little statement on the end indicating that each one is less than 0. In other words, the velocity is negative at time t equals 2, and the acceleration is negative as well. And now I can make my summary statement. The speed of the particle is increasing at t equals 2 because the velocity at 2 is negative and the acceleration at 2 is also negative. Part C. Find the time greater than or equal to 0 at which the particle reaches its highest point. Justify your answer. So remember, we're talking about a particle that is traveling strictly along the y-axis. It's moving vertically. We are not given the position function, but we know that y at t would be the position of the particle at time t. We know that the derivative of position is velocity. So this is the function that we were given in the setup, which is 1 minus the inverse tangent of e to the t. Here are some notes that you need to solve this problem. The maximum value of y of t will occur at a critical value where either y prime at t is equal to 0 or y prime is undefined. Inverse tangent and e to the t power are defined for all values of t that are greater than 0. So we don't have to worry about where y prime is undefined. So we just need to find out where y prime is equal to 0. Remember that y prime is the velocity function, which I've already typed into the calculator. So here's how you use the calculator to find out where y prime is equal to 0. Hit graph. So here is a graph of the velocity function. This is a graph of y prime. I can see that it crosses the x-axis somewhere very close to here, just to the right of the y-axis. Anyway, I'm going to choose second trace, and the 0 function will help me find where the function is equal to 0. So I choose option 2. When it asks me for left bound, I use my arrow keys to make sure that I'm definitely to the left of the 0, and I hit enter. Now it's asking me for a right bound. So I'm going to use my arrow key to make sure I definitely move somewhere to the right of that x-intercept, and I hit enter. So now it's asking for a guess. So just move close to where it appears to touch. The exact position doesn't matter. And hit enter. And here it is. This is the value of t at which the velocity is 0. 0.443. Before we go on to the last part of this problem, I want to show you how to store this value into memory. If we need to use it again, we're not going to want to use 0.443 because that's rounded and it will cause too much error. So we can either manually type in all of these numbers, or you can use the trick that I'm going to show you now. I'm going to quit my way out of this graph by hitting second quit. If I immediately hit the store button, it's going to take the x value that we just found and put it in any letter that I say. So this is a time t, so I'm going to put this value in letter t, but you can use whatever letter you want. I see the t right here above the 4, so I'm going to hit alpha 4. So you can see that I'm putting the value into variable t, and I hit enter. And it just pops up and shows you what value you just entered. So if I ever need this number again, I can just type t instead of writing the entire number. You'll see that's going to be useful in a minute. For our work, let's go ahead and write that down, but add this comment that this is the only critical value. We can see that looking at the graph. This is the only place where it crosses the x-axis. We are mentioning that this is the only critical value because that guarantees y at t has either an absolute max or an absolute min at t equals 0.443. The only question is, how can we prove that it's an absolute max rather than a min? We can use the second derivative test to determine whether y at t has an absolute max at t equals 0.443 or an absolute min. If the second derivative, or acceleration, is negative, that implies that there is a max at time t equals 0.443, because a negative second derivative means that the function would be concave down. So the horizontal tangent line is at a max. On the other hand, if the second derivative is positive at 0.443, that implies that there is an absolute min at that value, because if the second derivative is positive, it means that the function is concave up, which means that the horizontal tangent line is at a minimum value. Remember when I taught you how to take this long 10 decimal number 0.4430227241 and store it in the variable t? And I told you that would be very useful later. Well, guess what? Now is the time we're going to use this. Remember, our goal is to evaluate the second derivative, the acceleration, at 0.443. However, what we have typed into our calculator is the velocity function. So you have to remember that acceleration is the derivative of velocity. So that means we need to actually evaluate v prime at 0.443. And really there are 10 decimals here, but I'm just using 0.443 as a shorthand. So how do I use my calculator to evaluate the derivative of velocity at 0.443, etc.? Use the math button and find the derivative function. So I'm going to hit 8. We're using the variable x, and we want the derivative of the velocity function, which we have stored in y2. So hit vars, yvars, function, choose y2 where we have velocity. So this is now the derivative of velocity. We want to evaluate at that 0.443 number. So you have a choice. You can either manually type in all 10 decimal places, or since we have stored it in the letter t, we can just do alpha t. Kabam! So we have the acceleration at time 0.443, etc. is negative 0.455. I'm rounding. So the second derivative equals negative 0.455, which is negative, which implies that the position function has an absolute max at t equals 0.443. To justify the absolute maximum using the second derivative test, you have to be sure to mention the first derivative and the second derivative like this. Y at t has an absolute maximum at t equals 0.443 because y prime is equal to 0 and y double prime is negative. If the second derivative test seemed a little too complicated, you might prefer to use the first derivative test. Remember, this is the graph of velocity. In other words, this is the graph of the first derivative. Notice that the graph goes from positive to negative as it passes through the zero that we just found. So if we want to use the first derivative test, we say that y of t has an absolute max at t equals 0.443 because the first derivative is equal to 0 and because y prime changes from positive to negative at t equals 0.443. So the theory behind this is if the derivative is positive, that means the original function is increasing. If the derivative is negative, that means the original function is decreasing. So if the first derivative goes from positive to negative, it means that you must have a maximum at that particular t value. Part D. Find the position of the particle at time t equals 2. Is the particle moving toward the origin or away from the origin at time t equals 2? Justify your answer. Here are some notes illustrating the strategy that I'm going to use. The position at time t equals 2 is going to equal the position at time t equals 0 plus the change in position from time t equals 0 to time t equals 2. For the position at time t equals 2, I'm going to write y at 2. But what about the position at time t equals 0? In the setup of the problem, we were told that at time t equals 0, the particle is at y equals -1. So we know the position at time t equals 0 is -1. Now here comes the trickier part. Here's something that you need to memorize. The change in the position function is the integral of the velocity function. You need to memorize this. So one more time, the change in position is always going to be the integral of the velocity function. If I want the change in position from time t equals 0 to t equals 2, then I will integrate the velocity function from 0 to 2. And we can just put this in our calculator in the following way. Go to a clear screen on your calculator. Let's start by typing in -1 plus. Now we need the integral. So hit the math button, and the integral is option number 9. So I'm just going to type 9. We wanted the integral from 0 to 2. So I'm going to type 0 and then 2. We are integrating the velocity function. Remember, we have the velocity function sitting at y2. So you will use the vars button and go to yvars and choose function. And here's y2. This is the velocity function. So we are integrating the velocity function and we are using the variable x. And this should be it. So -1.361. I'm rounding up. You could put -1.360 and that would also get full credit on the AP exam. So we have now answered the first part of the question. Find the position of the particle at time t equals 2. Y at 2 is -1.361. How about the rest of the question? Is the particle moving toward the origin or away from the origin at time t equals 2? I'm going to give you some notes on this in a moment, but first I want you to look back at the notes I gave you in part B because they are analogous. Remember, I said that the speed was increasing if the velocity and acceleration have the same sign. I can say something similar about the position function and the velocity function. Add this to your notes. A particle is moving away from the origin if the position function and the velocity function have the same sign. If they have different signs, then the particle is moving towards the origin. we already know that the position function at time t equals 2 is negative. So we need to evaluate the velocity at 2 and see if it has the same sign. Actually, I just remembered that we already evaluated the velocity at time t equals 2 back in part B. And here it is, and it was negative. So here is our summary statement. The particle is moving away from the origin at time t equals 2 because the position at 2 and the velocity at 2 are both negative.